Hello and welcome back to Calculus 1, section 4.2, first and second derivative tests. It's not named like this in a book, but who cares about the book? So these two tests are utilizing derivatives to test features of the function. So we are going to first talk about first derivative test, and then secondly second derivative test, right? So first derivative test. So f dt, first derivative test. I'm going to immediately write the conclusions for it. So here is the theorem. This is what's happening. So if first derivative at point A is less than 0 on some interval I, then f of x is decreasing on that interval I. If f prime of A is larger than 0 on interval I, then f of x is increasing. It's a very simple concept. You have to memorize this, obviously, because this is the part of learning Calculus 1. And with this, we are able to analyze the function. So I'm going to have the most basic example in a galaxy, y equals x squared. We are going to find critical points, and then we are going to do the analysis. So the f prime of x here is 2x. We set it equal to 0. We get x equals to 0. Remember that this is from last class, critical number. Then we plug that in the original problem, and we get 0, 0. That is critical number, critical point. So now that you have a critical point, you know that that point is going to be min-max, or that inflection thing that we are actually working on today. So here is the procedure for the first derivative. So first derivative test procedure. You draw a graph and partition it using critical numbers. In this case, we only have a 0. That's your critical number. Then you pick test points. So these test points are in the regions from your partitions. And then you use those in your derivative test. So we have a test point -1, which gives us 2 times -1 equals -2, less than 0, meaning function is decreasing. You draw a decreasing piece above -1 because function was decreasing. And then you do the same thing for +1. So you pick any test points in those regions. And now you get larger than 0, which implies that the function is increasing. There you go. So what we found is the interval on which the function is decreasing, the interval on which function is increasing, and we also see, using our eyes, that at 0 you have minimum. right? It's very systematic. There's only one more piece of information that you need, and that is that aside from critical numbers, vertical asymptotes also partition your domain. That's it. So we're going to do now an example. Oh, well, now we know that this is a minimum, because we see over here that it's a minimum. I forgot to write the most important part, and that is the answer. So the answer is f of x is decreasing on negative infinity to 0. F of x is increasing on 0 to infinity. That's actually your answer. And you also include 0, 0 is a minimum. So this is how answer looks like. These are all of the things that you can discover using the first derivative test. All of the intervals of increase, decrease, and also because you have that, you know that each critical point is either min or a max. The next example will feature vertical asymptote partitioning. The problem is done the same way. Say y equals 1 over x squared. So you immediately find the first derivative, which should be negative 2 over x cubed. If you know, right, x to the negative 2, right, x to the negative 2, drop down negative 2, and then minus 2 minus 1 is minus 3. So the derivative is this. When you set it equal to 0, you get negative 2 equals 0, no solution, which implies no critical points, which implies no min max. You see that? So for this particular problem, we took the derivative, and when we set it equal to 0, it has no solutions. That means that there are no critical numbers, no critical points, no min and max in that case. Can we do the first derivative test? Yes, because even if you don't have either vertical asymptote or, well, we'll do the example with that, but you do have vertical asymptote, right? So now the first derivative test procedure says partition on asymptotes as well. And this function has the asymptote at 0. So I'll put VA, vertical asymptote. I'm still going to use the same two lazy -1 and +1 test points. And we do our first derivative analysis, right, at -1. Maybe I'll make it red one more time. So you plug in test points here, and you have -2 divided by -1 cubed. So the answer is +2, which is larger than 0, which means that the function is increasing. So you draw increasing piece here, and you draw, and then you test +1, which is -2 over 1 cubed. It will give you -2, which is less than 0, and that piece is negative, so it goes like this. Now you can't claim there is a maximum at vertical asymptote because there are no points on vertical asymptote, right? But you still have increasing and decreasing piece. And the answer over here would be f of x is increasing on -infinity to 0. F of x is decreasing on 0 to infinity. No min max in the problem because the critical number was the vertical asymptote. Now I just want you for a second to observe the graph for this and connect it with the graph that we have. If you don't know the graph of 1 over x squared, there it is. And you can see that there is increasing part up to vertical asymptote and then decreasing part after the vertical asymptote, right? So I want to challenge you guys with you working out this whole thing for f of x equals 1 over x. So work out the whole first derivative test for 1 over x. So you should be done by now because it is quick, right? We find the first derivative, which is negative 1 over x squared. Set it equal to 0, find there is no solution, which means no min-max, skipping all of the no critical number, no critical point, right? Therefore, no. And then once we get that, we have the so once we have this, we say that there is vertical asymptote. So first derivative test would be, again, partition at 0, right? It goes from negative infinity to positive infinity on the number line. And then there is a vertical asymptote that partitions. Same old boring -1 and 1. And now the first derivative at -1 is -1 over -1 squared, which is -1 less than 0, function is decreasing. First derivative at 1 is -1 over 1 squared, which is also -1, so function is still decreasing. So in this case, function is always decreasing, but there is a vertical asymptote, there is a break in the domain. So what's the answer? You will say f of x is decreasing on negative infinity to 0, union 0 to infinity. Boom. Done. That's the answer.
What about the no min max?
All right. No min max.
Well, do you want us to write that every time?
To be honest with you, today is the first day when I started including no min max in this answer. You can watch my previous 3 classes when I taught this. I've never included it before. So you are a pioneering class, all right? The next one is going to be the f of x is equal to e to the 4x. So try this one. Scroll up. Scroll down. Yeah, what can I do, man? I'm just like that.
This one, I did 4e to 4x equals 0.
Good.
So it's 0, but then divide by 4.
Okay.
So e to 4x equals 0, but not so I can really do it like that.
Exactly.
Alright.
So what are we having here? Okay, so derivative is, that's good. So derivative is 4e to the 4x. Now what happens when you set that equal to 0? Very good. No solution, right? Because e to the x never cuts through x-axis, so no solution. Which immediately means no min max down the line, right? Do we have a vertical asymptote here?
Yeah.
No, right? No, ln has the vertical. This one has a horizontal. So we don't have the critical points. We don't have vertical asymptote. Do we get to partition this? It's all just one partition for the entire domain. So, first derivative test, we can still do it. It's just that we don't have anything between negative infinity or infinity. We don't break it at all. You just pick one test point somewhere. And the easiest one is clearly 0, right? The easiest test point. So I'll write here in blood, no partitions, because no critical points, no vertical asymptotes. So the whole thing is just one partition. The entire domain is one partition from negative infinity to positive infinity. And now we go f prime of 0 is 4e to the 4x, oh, sorry, plug in 0 there, which is equal to 4, which is larger than 0, which means function is increasing, so the whole thing. And the answer is f of x is increasing on negative infinity to infinity, no min max, because such is life, right? So this particular problem did not have any material to do partitioning, had no critical points, had no vertical asymptotes, and we had to treat the entire domain from negative infinity to positive infinity as one single region to be tested, and we found that the function is increasing on the entire domain. Now we obviously know that's the case because e to the ax graph looks like this, right? So calculus never lies. It always works. So it was cool kind of to verify that using calculus. So next time when you are, casual conversation and you say, but e to the x is always increasing, if they say prove it, you can do this. The next problem for you to practice is f of x equals sine 2x. I know how much you love trig, so I don't want to deprive you from practicing these things. And then hopefully, when you get home, well, tonight and tomorrow you'll be preparing for the exam, but on Wednesday after the class, you might run tangent and secant or something else, right?
I don't feel bad. I just think it's funny. Wait, for this one, sine 2x is the 2 technically with the x squared. How would you derive that? I was gonna do the product.
Negative cosine. Yeah.
Oh, that's it?
Yeah, derivative of
No,
sine.
it's just
It's just chain rule. Derivative of sine is negative cosine.
No, it's just
Cosine. Derivative of cosine is negative sine. But you're either way. I mean,
Yeah, yeah. Derivative of sine is negative cosine.
no, it's just cosine. But derivative of cosine is negative sine.
Yeah.
You know what I'm saying? It's just the opposite.
Yeah, it's just cosine, right? Yeah, then it's cosine.
So what test points are you
2x. Yes, but it's chain rule. Either way, it's still chain rule.
Good answer.
So cosine 2x times derivative of 2x, which is 1, so that is enough. So just cosine 2x. And the way that a cosine works, it doesn't matter. It's just a cosine.
So would this just be cosine 2x?
Yeah, it's just a cosine with a slightly increased.
But why wouldn't I mess 2x this time?
That's why I had.
And 2x doesn't matter because it's chain rule. F prime
You want to talk
G
about
times G prime.
some rights,
And G prime is 2x.
So F prime is that sine. So
Yeah, so sine so it turns to cosine of G, which is 2x. So cosine of 2x times G prime. Derivative of 2x
you're right.
is 1.
No, you're right.
I thought that too, but I don't
So I
think.
get
So it's just a cosine with
so it's just cosine
with a double
2x
frequency.
times 2. So no,
It's
then
times
it's
2, it's times 1.
Oh,
2x is
Oh, no.
linear.
No. Look, you take the f prime, which is sine, then you take the cosine, then you write 2x
Yeah, so
times 2.
the 2 doesn't go there. 2x is a linear. It's what's y equals 2x? That's linear. Y equals 2x is linear, therefore it's 1.
No, 2x is because would it be cosine?
Yeah, 2.
You're literally
So
ginger
2
garbage.
cosine 2x.
You know those carrots that are unfulfilling? That's you. It's my entire relationship. That's what your parents would do.
No, I go home after class and that's right. Well, that's so I think the notes on positive.
No, I'm baby crazy. No, I just couldn't.
Yeah, it's 2 cosine 2x. Really?
Not do that. So I started playing League of Legends towards the end of the year, and I would just get so butt flustered at like No, I didn't yell at her, but like whenever I was like, my fucking teammates, this makes teammates garbage. They're like seriously by the Holocaust. Like they need to go through the Holocaust and like just
All right.
everything.
You all have it?
Yeah.
So we know that the derivative of sine 2x is? And when we set that equal to 0? Exactly.
What? Yes. So that's a. Wait, pi over 4.
Right?
Oh, because it's 2 pi over 4.
So a little bit of trig equations from your pre-calc 2 class. There's going to be much more of this coming up.
How many points do you need to? Oh, but it's oscillating, so it's going up and down.
Yeah.
Yeah.
So it's going to be a lot of these.
Do you just want like 3 points just to show like the?
Well, we'll see how this works. So we have this now, and add this. These are critical numbers, obviously.
Wouldn't the first critical number be at 0?
No, for sine would be a 0.
No, derivative, meaning that rate of change would be at the minimum maximum, right? So for cosine, it would be at 0, because sine begins with a up-down, and the...
But the maximum of 2x is at pi over 4, where the cosine 2x is 0 at that
the
point.
cosine begins, if you just put sine x, cosine begins at a maximum.
Yes.
So then the 2 and the 2x doesn't make a difference because either way it's still starting at 0.
Yeah, this 2 has no effect on
Yeah,
it.
and the other 2 doesn't have any effect because...
It does, because it would be, this 2, it would make this into a pi over 2 or a pi over 4 or pi over 8 or something else, because that one controls the period. So that would shift these values. First derivative test. Now I have infinitely many partitions. Pi over 4. 3 pi over 4. 5 pi over 4. And then negative pi over 4.
Right here, at 0, it's at a maximum.
Cosine, yeah.
Yeah. So it wouldn't be pi over 4, it'd be 0. X equals 0 is at a maximum.
You are looking at the derivative function. So you have to look at zeros of that function, not at maximins. If you graph sine.
Maximum is derivative equals 0 because that means 0 rate of change.
Yeah. So 0 is at pi over 4.
It would be at 0. X equals 0 means that it's at a maximum, which means at the maximum it's 0 rate of change.
You are confusing the two functions.
I am not.
Yes. Because the sine.
At 0, it's on a slant. It would be a negative derivative at pi over 4. It would be going down at pi over 4, therefore the derivative is negative.
You are confusing two functions. Graph sine and graph sine of 2x. Graph original function.
I did.
Okay.
I have it right here.
Great.
0, maximum.
No, that's a cosine function. Graph sine function. Graph original function for the problem, not the derivative. Graph the original function sine 2x. And tell me at which point you have a max. It will be pi over 4. Sine 2x, you look at pi over 4, and you will see that it's a 2. Because it's sine. Sine is the original function, so it has the maximum at pi over 4. Cosine is the derivative, and it has a 0 at pi over 4. Because they have to obey. So partitioning is done at pi over 4. Every pi over 4 and then 3 pi over 4 because the period is now pi. And within the period everything happens twice. Therefore we have pi, 3 pi over 4, 5 pi over 4, 7 and 9 and 11 and so on. So now when we do the first derivative test, f prime computed at pi over 4. Oh, sorry. Test points first. Test points. Test point at 0. Pi over 2. Pi. 3 pi over 2 if you want to, and so on. And negative pi over 2. So all of these are test points. Let's go with 0. The derivative at 0 is going to be 2 cosine of 0, which is 2, which is larger, so it's increasing. F prime at pi over 2 is 2 cosine of pi over 2. Cosine of pi over 2 is, oh sorry, it's 2 pi over 2, so it's pi. It's negative 1, so it's negative 2. Less than 0, decreasing. F prime at pi would give us 2 cosine of 2 pi, which is cosine of 2 pi is 1, and then times 2 is 2. So this one is going to zigzag like this forever. And then we see that we have a min at negative pi over 4, a max at pi over 4, and then a min at 3 pi, and a max at 5 pi over 4, and so on. So writing the answer for trig functions because they're periodic is usually a little bit tricky, but it can be done. And the min and max situation as well. So let's really work hard to make that happen. So these are the points of interest which are telling us. So let's see what can we do for the answer. It's going to be tricky. So f of x is increasing on, so we have negative pi over 4. Oh, no, I have to take the 3 pi over 4 because both are positive. So 3 pi over 4 plus n pi, comma 5 pi over 4 plus n pi. Okay, so these are all of the, and then this n is negative 2. N could be any positive or negative number, right? Because it happens, does it happen every n pi? So 3 pi, and then plus n, there will be a 4, it will be 7, and that's the next one, right? Yep, good. So n is the set negative 2, negative 1, 0, 1, 2, going on to infinity. Oops, 3 dots in front. F of x is decreasing on pi over 4 to 3 pi over 4. So pi over 4 plus n pi, 3 pi over 4 plus n pi, and then same, so it goes for all integer multiples. So as you can see, for trig, it's a little bit tricky. Now, mean values at x equals, minimum is 3 pi over 4 plus n pi, same n, and then max at x equals pi over 4 plus n pi, so n is the same n. And that's the answer. So periodic functions, just a tad trickier. This n pi allows us to go infinitely to the left and infinitely to the right. Yes?
Just a question. For the min and I guess the max, why would, like, for the min, the 5 pi divided by 4 plus n pi answer? Because aren't the mins the same, like it always reaches like that negative 1 point?
Negative 2, right, in this case?
Yeah.
No, sorry, you're right, negative 1. It reaches negative 1.
Oh, yeah.
You're right.
But I mean, you get what
there is, there are infinitely many of them. So that's this n pi situation here. So you pick one of the minimum values, any one of them, and then you introduce the other infinity of them by adding n pi in this case. Now, if this was just sine x, then you would be adding 2n pi, because the period would be 2 pi in that case. So so if you are, depending on how much you guys studied trig, you know that this every time when I get excited, it crashes.
This is why we can't be happy. No, see,
All right, so talking about sine, let's see if this crashes again. Of course, as soon as I try to draw a sine function, it explodes. Oh, come on. It crashed 3 times. Come on, Windows 10, you can do better than this. Like, my Windows 8 never crashed. And 10 is much better operating system, it's just one note is not working on it. And it's annoying. It won't let me draw the graph. It crashes every time I try to draw a sine. He had no issue with the squiggle. Yeah, great. Yeah, I'll have to restart because I'm not sure what's going on now. Alright, well, it'll be part 2 then.